We evaluate this function at 1, h of 1. We want to plug in 1 for x, but we first have to decide whether we are going to be using the first piece, the second piece, or the third piece, which all depends on the conditions that each one of those pieces have. So we look at our x value that we're plugging in of 1, and we look at each of these conditions, and we ask ourselves which one of these inequalities is true when x is equal to 1. And only the first one is true. It will always only be one piece that you can possibly plug into when you are evaluating a piecewise function, and that is important. There is always only one piece that you can use. You should never be evaluating a piecewise function and plugging your x value into more than one piece. So I'm going to use 1. And I'm using 1 because 1 satisfies that first inequality. 1 is less than 2. So plugging 1 into that first expression, we have 1 squared plus 3, which is 1 plus 3, which is 4. Now we want to evaluate the function at 3. We need to determine which piece of the function is true when x is equal to 3. Well, 3 satisfies the second inequality. So we're going to be using piece 2, because if I replace x with 3, the second inequality will be true. 3 is between 2 and 4. So now I'm going to be plugging the x value of 3 into the second piece of the function, which is just 7. Now when you plug an x value into a piece that is constant, that has no x in it, you see there's no x in that second piece, it's just 7. You just get 7 out. There's no work for us to do. That does not mean that we should multiply the 7 by the 3. We just simply get 7 out. Now moving on to the third evaluation, we want to plug 4 into this function. We have to figure out which piece of the function we're going to use, and we're again going to use the second piece, because the second piece of the function is true if x is greater than or equal to 2 or less than or equal to 4, and 4 is less than or equal to 4. So we're using the second piece because when we replace x with 4 in that inequality, it is still true. And again, there's no work to do, we simply just get out 7. Lastly, if we want to plug 5 into this function, we will be using the third piece because 5 is greater than 4. If I tried to plug 5 into any of the other pieces, if we look at the first piece, that would say that 5 is less than 2. That is not true. If we look at the second piece, that would say that 5 is between 2 and 4. That is not true. So the only piece that it works for is the third piece. So now I'm going to be taking 5 and plugging it into this expression here of 2x minus 1, giving us 2 times 5 minus 1, which is 9.